Oh. Oh. God damn. Now we have to write fucking collision code. And not the best kind. So annoying. So. It should be something like this. But I think we just do I here, and then we just set the partition data to be correct. But can you access a buffer like this? Do you not have to do .load? Hold on. Okay, yeah, we can. It's only raw buffers and byte buffers where you need load. Yeah, because here we know what the data type is, so it knows how to open it. Fairly simple when you understand it. How data type works. Just a matter of interpreting some bits. But then that means that it should be something like this. And then here, don't know if we need a for loop in here. I think we should just have to say if quadmin.x equals quadmax.x. And then we have 3 of these. This then allows us to decide what to do. And this should be an else if. And then this one is an else only. Because one of these would always be true, right? Because the quad is always... How do I put it? It's always planar, I think. So... if x equals x, what does that mean? It means it's z or y. And then we have to figure out which one is it. If quad min dot y equals quad max dot y, else. And I think this is how they all have to work. Because for each quad, we can calculate what we need to check, and then we only need to check greater or lesser than. And we're only checking for things that we collide with. Yeah, so... if x and y are the same... Well, let's think about this. I think only one axis can be the same. So I don't think that's accurate. I have to draw this. So we have this here, right? Let's say this is one quad. Then that means that in this scenario, this is y equals y. Because y is this direction, right? This is y. This is x, obviously. And the other height is z. Because the z is different, the x is different, y is not different. So then all we need to do is just say if quad min dot y is less than tile position dot y, then we do a check here. If quad min dot x is greater than or equal, no, it's less than or equal to tile position dot. Well, no, actually, let's do it the other way around. Let's say if quad min x is less than tile position dot x and quad min dot quad max. No, let's do it the other way. If tile position x is greater than quad min and quad max dot x, no, and tile position. This is something that I've learned. There's like, whenever you're doing a like greater than or equal to or position check, always put, there's like a subject and like an object in these kind of scenarios usually. In this case, the tile position is the subject because it's what we're passing in, it's what we're checking against something. Always put that first on the left. It just makes it so much easier to think about without accidentally flipping it around. So now we're checking, is the tile position greater than the quad min? Yeah. Is the tile position lesser than or equal to quad max? Yeah. However, the quad max is actually quad min plus that. Because if this is true, this is where we only need to check, like, okay, we are within, which means the only thing we need to check is, is this up or down? So if quad min is less than tile position, This is a little tricky. Man. I guess that's fine. I guess that's fine. But the issue here is that I can't actually... No, it will work. It'll work. Let's just do this. Because the problem is that what we have to do is we have to figure out, like... if we're inside the building. And to do that, we're counting how many times we cross these quads. But if you're inside of the quad, then that means that it'll always count as crossing both down and up. So that was so I was thinking like, oh, okay, but that means then that this direction will count as crossing like this and that, and then it'll count as crossing twice, which means it's outside. But no, or actually, yeah, it might. Yeah. So we can't count as being inside. When we are inside. Is that real? No, it's doable. But it's only doable in one other way, I think. Maybe. So sure. Let's test this. I think it's fucked up. Let's just do 16, 16. Doesn't need to be bigger than this. Right. So this is a house. And then we need to check this tile here. So what's gonna happen here then is that for this, we then have to check down, which will trigger true, and then up, which will also trigger true. And again, that means green, green. But then we have to check the others too, right? And then when we finally get to over here, we have to check here. Have an idea. I have an idea. Instead of these being booleans, this could be integers. And they could all be set to 0. And then what could happen here is that we do this. If quadmin.y equals tileposition.y, then we say because here we're checking what? Up? No, north, south. Here we'll say north equals 2, south equals 2. Because we're inside of the quad, that means that it's guaranteed to succeed. But this is wrong. This is... Oh, this is why. Yeah. And this should also be tile position.z. Like that. But I also want to add if north not equal to and south is not equal to. However, this is wrong. Now that I look at it. This should just be this. Right. And then here we have to say if it's less, else. Then we're gonna say well, what if we make them booleans again? And then we make more booleans. But these ones are called like that. And then guaranteed north. True. There. Then we can check for that. Then, okay, if quad min is less than tile position, then we say south. No, you do south equals not south, right? And here it's north equals not north. Then that's the whole thing for y. Then we just need the same for x and z. Except here it's going to be y instead of x. This is x. Then this is west, east. What did I say? If tile position is greater than east. No. Then west. Just want consistency. I think this should be okay. And then here we have to figure out if this should return a boolean. However, this is not so simple. We can't really have a room start here. No, we can. It's the partition. Never mind. Right, we're checking. That's why we need 2 for loops. Because we're checking every room. And that's what we need to do here. For int u equals partition data dot room start compute room fucking ducks. So what does a room need to be here? A room, there needs to be a buffer for rooms as well. And it doesn't really need to be a read-write buffer, but at this point we might as well. But here we have compute room quads. See, this could be a byte address buffer. But it would suck, I think. I don't think we want to do that. But this needs to be a compute room buffer. And a room compute room data. A room should contain its building ID. It should contain its, maybe its floor. I'm unsure. I don't think it needs that, actually. It doesn't need... it should contain room transparency. which I will call it opacity instead. And this is where we need to store in uint quad start uint quad count. Right, so we now have the room start, the room count for the partition data. And then we need to go through compute room buffer using I. Let's see, the room buffer no, it's not so easy as this. Well, this is a uint 3 here. This needs to be a compute room data buffer, right? That's the problem. And compute room quads could maybe be... Yeah, we can make a struct for that too. That just says struct quad int 3. It might need to be float 3. I just don't like it, but for like monogame compatibility, it should probably be a float. Lizards are so weird. Uh... Basically, this needs to be... what is it called? Min vec 3. Max vec 3. Right, and then we can have a quad. And then we can have a... compute room quads can then be a quad instead. Yeah. And then here, instead of XYZ, we then say min. And here we can say quad. And just call it a quad. Then we don't need to have that. Right? And get rid of that for now. And then we can replace this with quad min. I think that is more nice. More nicer. As such, but this is incorrect. This is where we need the for loop here. For u room buffer dot quad start. U is less than compute room buffer I dot quad start plus compute room buffer I dot quad count. But I think that sucks. So let's do uint quad start and quad count. Which should just be... we can just do this right away. Right. That's what the quad count is. And then that needs to be here somewhere. And this is then a U. This should be correct. And then here we should say if north or guaranteed north. Oh. And needs to be 6 south, south, west, east, up, down. If that is true, then we're gonna return true. And then we're also going to set info out equals we need to say structure info well, actually, we just need to say info out dot building ID info out dot room transparency, and then we just need to fetch that, right? Because we know which room we're in right now. So all we need to do is say room compute room buffer I dot building ID equals compute room buffer I dot capacity. Something like that. I'll be right back. What was I thinking? Yeah. What we actually need to return here is... It's really annoying. Because the reality is you can actually have multiple buildings potentially next to each other. I'm just thinking. Do I need the building ID? I kind of do. It's entirely possible to fetch multiple IDs, but it just sucks, man. It's just annoying. Because it's not as easy as using lists or arrays in C#. Like, you have to store, like a count and shit and stuff like that separately. It's awful. I'm just not sure how to handle it. We don't need room ID. Because what I'm just gonna do is we're just gonna fetch the highest or the lowest room transparency, and that's it. But as for a building, we need to know, I think. Shit. Can I even support a wall that's thicker than one tile? I think I could. But I think it would suck. Because the issue is, like, in order to determine how to render something, we need to know some things, right? So we can fetch the building transparency. That's all well and good, right? But that doesn't tell us how it should be transparent. Because if there can be two different transparencies. There can be room transparency and there can be building transparency. And the difference is that the room transparency handles both front and back transparency. Oh shit, that's even more annoying. Yeah. But building transparency only handles transparency of the back when the innards are visible. But if the facade is visible, it sets the first tile that it finds to be transparent, then it skips drawing everything else until we leave the building. And find the floor. And that's why I need to be able to get a building ID. But the problem is that, like, I was thinking, yeah, we don't need building ID to... Like, a building ID is never gonna overlap. But it could. However, I could, like, kind of solve it with hacks to some degree. I could just make them not overlap. Kind of. Kind of not really. Because the issue is that, like, let's say we make a big castle or something. And then you have two sections that are connected, but they're like really big. So you might want to switch the transparency. Like if you walk over into this wing here, then maybe this should be transparent, or this should be opaque until you walk over there. And then this is like a door here that you walk through. So when you walk in here, then this becomes visible and this becomes opaque. But the issue then is that that would need to count as a building for me to be able to handle, like, the transition to the entire thing being visible, like the entire floor. And that's the problem, because now we have buildings overlapping here. And that means I need a system to be able to find multiple buildings. I mean, I can do that. It's just annoying. It's just so annoying. I hate doing arrays in the GPU. Like, it's so ass. Because it makes comparison so much harder. It just makes everything so much harder. And I'm not sure. Yeah. So what we need to do is something like, instead of this being a building ID, structure info. So this would then need to be a building ID of maybe 4. Is that how it's declared? Yeah. So you need a building ID of 4. But then, this is what I hate about it. Now we also need a uint building. Well, we don't need a building count, I guess. What you can do is... We'll have to... Here, info out dot building ID, right? What we'll have to do is we'll have to set it to like a value that counts as being null. Now this is a uint, but we can still limit it to like 255. I don't really know. It would be easier if we just make it an int. uints are slightly better, but in this scenario, let's use an int. And for the building ID here, I want to use an int. No. What was I thinking? Right. Then we can set them to -1 instead. -1 is a much easier way to do like a null value. But then the annoying part here is we actually have to do this here, I think. Right? So here, if... Well... This is for the quads, so we do this after the quads. We do it here. And these actually need to be reset. At the end here. And then if this is all true, then we need a for loop in here. It doesn't need to be a for loop. We can say if info out dot building ID 0 equals -1, then we're gonna set info out dot building ID 0 equals to compute room buffer I dot building ID. It's... It's kind of shit, but... we can say int building ID equals that. And then we can say if info out dot building ID the thing is, because I'm trying to assign a building ID again, that means we have to check through all of the array entries and check that it doesn't exist already. This is why I hate this. Like, it just makes everything so much more complicated, like, instantly. Then we just continue. But what we should do is we should fetch float room opacity equals compute room buffer I dot opacity. And then we'll say if room opacity is less than info out dot room opacity, then we'll say info out dot room transparency equals room opacity. I need to change that. Because I feel like transparency somewhat implies that a transparency of 1 is that it's transparent. But it should be a 1 is opaque. So that's why I don't like it being called transparency. But we should also say if float compute building opacity equals compute building data building ID, but that doesn't contain anything. Yet. We need to decide where the building opacity should be stored. But that's what it should be. It should be like that. And then the same thing here. If building opacity is less than info out dot building opacity, then info out dot building opacity equals building opacity. That shrimple. We don't need to check this anymore. We're already checking that up there with the continue. So we just need this 2, 3. Else. Continue. So compute building data. Compute building transparency. Here we have a room data. And that can contain the opacity. But then the building data, I don't know if it really needs anything at all. Is the only thing a building really contains otherwise is like, yeah, it's got a quad that makes up the entirety of the rectangle of the building, but that's not needed. It just isn't. So the only thing that is needed for the building is the opacity, I think. We might need to know, like, the floor. Not necessarily. We do actually need to know the room ID. Unfortunately. And the reason for that is because in order for me to be able to calculate it's a little heavy, it's kind of shitty, but basically in order to calculate the transparency of a wall, we need to know how high up it is. And that might suck. I don't know how heavy that's gonna be. It might be really bad. We'll see. I can come up with a solution-ish here. But it's not easy. Basically, we have to go. If I find a wall that should be transparent, we then have to calculate whether the room. We have to check. No. If a room has transparency, that means that the front wall should be transparent. So we need to check if the tile in front of us contains that room. If it doesn't, that means it's the front, right? Fuck, that's so complicated. It's really easy if you just have one room, but the fact that it might have up to 4 rooms, that's like, ugh, oh my god. So then we have to compare the remaining rooms and then use the room that disappeared when we're checking forward as the room whose transparency we want to use. I think. Ugh. Yeah, something like that. We can't just do this. This makes sense when there's like 2 rooms next to each other and you're like walking between them. But what this kind of means then is that yeah, we have to fetch the individual opacity. I hate it. I hate it. So in that case, is there even any point in me fetching the opacity here? I don't think so. Because which opacity we need to combine or like choose between might be... Oh, what I was even saying. Oh my god. I hate this part. The whole like the buildings might overlap with each other business is the worst. I hate it. And same with rooms. And it just that's just how it is. Because I can't do anything else. It has to be that way. Because a room might have to govern two different sets of wall. Think. Yeah. One way or another it has to. I'll be right back. Hello. Yeah, arrays on the GPU is just so ass. Like, they're really, really difficult and annoying to use. I wish you could use lists so bad. Too slow on the CPU? Well, it's just that it's part, like, I need it as part of the render step. That's the thing. Because what's happening is that before each tile contained the room ID, but even then, the rooms can overlap. So that meant that each tile had to contain a 4-length array of IDs. And then I had to fill those arrays with like a null value that I assign myself. So it's like -1 is null, or 255 is null, something like that. And that means that in order to go through that and check, you have to like write a bunch of code for like, or you have to go through it with a for loop, and you have to check, is it 555 or 255 or whatever you set it to, and then you break it and shit like that. But now I've moved away from having rooms assigned to tiles, so now it's just it's just an area, right? But that comes with a penalty, because now in order to check like neighboring tiles for things, that means we have to do collision check against the room area for each neighbor that we need to use to calculate how the transparency should look. And that now also means that we still need to like fetch the ID of the room that we're finding and store that in an array. And it's just like the fact that you have to write all of these null values yourself, and then you have to iterate through it, and you also have to write a count, right? Kind of. Well, no, well, we don't need the count. I decided that we don't need the count. But yeah, here, like I have to write these to -1. Then we have to write the building ID to, like, we have to go through them each and every one here. And we actually need to do the same thing here with rooms. So room ID. This should be just I think. How come the rooms overlap? They just do, because this is a room, right? And we need to know that these tiles over here on the right also belong to this room. And this can also be a room. And you see, they'll share a wall. So it's like either I do that, or I just say that, okay, a room is only like the bottom right. But then what about the left side? Like, what about when it is the leftmost extreme? Then that's like an edge case that looks like this, and then the rest looks like this, or... And then, okay, what if the vertical wall needs a little bit of transparency when you're inside? Should that just be when you're inside of this room, or... So that's why they need to share space, because they might need to govern the same tiles in some edge cases. And so then we just, if we find two rooms, then we have to go and find the lowest transparency value between the two, and then we use that. And the same is true for buildings, and that's why this started to be a little bit annoying, because I was hoping I wouldn't have to do it. But like, what if you have a large building, like a castle or something, and you want one section to kind of be its own building in a way, so that you don't have like vision on everything. Like, let's say the left is like a cathedral attached to the castle or something, and then this is a gate, and you want to move over here, and then that like shows the cathedral. Now that cathedral has to count as a building, but then they'll share a wall here, and then we're like back with that issue again. Yeah, because I'm trying to create like a dynamic system here, and that's why it's so annoying. Yeah, it could be something like that, but there's still gonna be overlaps. Because, like, I don't know. Yeah, you could use triggers and stuff, but it... No, they would still need to overlap. To some degree, I think. But it's doable, it's just really annoying. To have to store a bunch of IDs. Building, 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 building. Where's compute building? Wait, compute building data. Is it all it contains opacity? I think so. I think we'll remove that, and we just fetch the IDs. Yeah. Nah, let's not do a building count. Okay, so we're fetching the structure info here. Then what? What is this? Get room height. Yeah, we don't want that. Get room base Z, we don't want that. Get room transparency, we don't want that. Get building transparency, we don't want that. Set final wall. That one we'll have to get back to. Find tile rooms. This is kind of what I was doing already. Light origin building. That's like that. An int. That's the light. We'll get to the light later. I don't want to deal with that right now. Draw tile selection equals 1. So here's our Z, right? And then here we have a structure info. And we do full has structure info. Equals get structure info. And we say int 3 current tile position equals int 3 floored tile position x, y, z. Then we need a partition data. RC data, partition data, structure info. How do you write this? Out structure info. Do you just write it like this? But then we also we actually needed to fetch 4 tiles, I think, for every pixel. Has front structure info. Then this is current tile position a minus int 3 0 1 0. Front structure info. Back structure info. And then below. Actually, I don't know if we need below. We do need it later, but not like this, I think. And this is back, so that's plus in 3 0 1 0. Something. This shouldn't matter. This isn't a thing anymore. To the point where we should go and delete this. Tile state isn't a thing. Height map sample isn't a thing. Level stencil couldn't be a thing. The depth stencil is a thing though. That handles rendering acceleration. The level stencil isn't a thing. Detail text isn't a thing. Selection texture isn't a thing anymore either, but we can handle that later. Because this here I was loading from a texture, like the size or the height of a building from the texture, which was terrible. And now we have infinite errors here. Now we have tile states, which maybe we should have a tile state, I'm not sure. At the end of the day, it really depends on how it runs. Because it kind of means that we need another one here otherwise, which is, well, that's only needed if we find a wall. And tile type is actually something that we do want. But it is something that should be handled differently later. Because right now we're only rendering a tile, but we actually should have code that finds a top of the tile. To see if we are striking the top of it. And then render differently if we do. And that would be a better solution here. See, it's just scary to have to do a lot of checks on neighbors, especially when it involves collision code and shit. Or like room testing and stuff. However, the game is very light to begin with, so I don't see any issue, right? Because when I was working on the 3D renderer before, that was still running fine, and it was fetching and testing stuff from its neighbors and doing calculations between each other in like a very, very shitty manner. So here we're rendering like 1/100th the amount of tiles, right? And so it's just not a problem, I think. But technically, it is the same amount of pixels, so it might not matter how many voxels are on the screen. But we are traversing much less. But with the traversal, we might be checking more stuff, unfortunately. We might want to... I don't know. I could do something. Actually. Because we only need to know how far up the wall we are if we are inside of a wall. Because it's only inside of a wall that we are like actually at a tile that needs to be rendered in a certain way. So there, inside of the structure info, we could contain a quad. Or more specifically, the Z value. Like an int2 Z min max. Wall Z min max. Bool found in wall. Info out dot in wall equals false. Dot we set it to something like this. And then here we have to set it here. Hello, Chair, how's it going? In this one, we have to say min info out dot min equals int2 quad.min vec3 dot z quad.max vec3 dot z. I think this is just how it should be in all of these guaranteed ones. More or less. Ish. Hopefully. Maybe. I'm alright. Coding is going alright. It's a little bit complicated stuff right now, which is really annoying. But it's going forward. I'm writing renderer code now, and it's a lot harder than writing normal code. Tonight we're going on the Bickering Bunch to play Final Fantasy XIV. Kib needs a reliable tank. And also to get past the queues faster. Oh, I don't like doing this. This is so, I don't even mind writing shader code for the most part now anymore. Like I understand how it all works. It's just when it's annoying, it's just so annoying. Ugh. I'm gonna open the window. I want some air. There's cheese all over my floor. Need to fill my water jug? Sounds like a good plan. Sounds like a good plan. I think I'm gonna grab a little snack. So cute, shrine girl. Oh, we are at the halfway mark. Air is good. It's very good, actually. Breathing is nice. Mm. So this sausage sucks. It's terrible. Oh, we also need to set the room IDs. -1. Yep. And then what? Actually, we do this. We don't do a continue here. We're gonna do this. And then here. And then here we're gonna do and instead, and this is gonna be does not equal. Right? And then we need to do the same thing down here. Not this. Actually, that one's fine. Oh no, yeah, room ID is just... we don't need to set that. That's already set to... that's just I. Is that true? That can't be real. Is it? Room start, room count. Partition data. Yeah, that's not right. That... we need to get an int room ID equals, it's like world data. Partition data. Partition data room start. Now this doesn't help. Do I need to have a buffer for each type for the partition too? I think so. But it's just gonna be an integer. But it could still be lots of integers. Okay. Read only. So we kind of messed some stuff up. Because we have these read-write structured buffers here. But in DX11, we can only have 8 read-write structured buffers. Fuck me. In DX12 you can have infinite. But I would like to, like, there's no real reason to target DX11 over 12. Like, who doesn't have a DX12 GPU? But I do think it's okay to target DX11. Damn it. Now see, here's the issue. These are all the buffers I'm using right now. But a lot of these can be removed. A new selection texture can be removed. Detailed text removed. Depth stencil not removed. Selection remove. Level stencil, height map, object collection text cannot be removed. Compute shadow sources. Compute grid highlights static. Dynamic. Which is a bit sad, but what you can also do is you can assign like a maximum size to these buffers. And then you just use one buffer for all of them, right? And you say like, this one is called compute static light areas, this is compute dynamic light areas. Then you just say that it's like 10,000 bits in size or something, or 10,000 bytes or whatever. And then the first 5,000 is the static, the second 5,000 is the dynamic. That way you have reduced a binding, right? Got a hair in my mouth. But I guess all of these buffers will have to be just structured buffers instead. Which unfortunately means that the allocation system I have written before is kind of ass now. But tile data, actual tile data should still be read-write. Compute building transparency. This one was read-write because it kind of made it felt faster, but I think these are actually like one write only, so it doesn't really matter. The reason I want the compute tile data to be read-write is so that I can just write a section. However, I think you can do that anyway, even if it's a structured buffer. You can just update the section of it using set data. I'm a little stun locked. Oh yeah, like I was saying, so compute world data count container. Partition data. See this here. These should all just be uints or ints, it doesn't matter. So this is then compute partition static lights. Static light buffer. Right, and then this needs to be everything. Dynamic light buffer. Well, this is static. Shadow buffer. Dynamic shadow buffer. What else? Static light, dynamic light, static shadow. Partition room buffer. Building buffer. What else? Object. I don't know if I need that. So it's room, building, light, shadow. Combat object. Does that matter? I don't know. I don't know. I think it should just be these for now. What did I do? Oh. Right. And then we can go back down here, and then here we have to say room compute partition room buffer. And this is where we have the partition data room start. I.x. And then from the room ID, we can then get the building ID by just saying compute room buffer room ID dot building ID. Yeah. And then what is this? This is compute room data. So that's what we should set here. Compute room data equals this. And then here we say room data building ID. Quad start, quad count. Compute room quads U. I think that makes more sense. So here we iterate through the room IDs in the partition data. Well, this isn't even the room IDs. This is just the start position and the end position inside of the partition room buffer. And the partition room buffer contains room IDs in random order. It doesn't matter what order they're in. It's probably from low to high, but either way. And then we go through that and we fetch the ID from there. To here. Then we use that ID to access the actual room buffer to fetch the room data. Then we use the room data to fetch the building ID. And also to fetch the quad, start, and count. Then we iterate through the room's quads here. Yeah. We have done a lot, but I really don't want to stop here. I'm just a bit out of it. As usual. I think that makes sense. But we need to write some notes here, otherwise this is gonna turn into a mess. Added new buffers for partition IDs for all buffer types. Needs to be generated in C#. Try reverting to set data for most structures. See if we can set data segments. Because I don't know if we can. Because there are multiple ways to set data segment. That's gonna be like set data. But here, for example, quad room buffer manager. So compute room quad buffer manager dot set data all room quads list managed buffer start index. Graphics buffer. We can do a partial upload. I'm just thinking, comparing how monogame's internal structure works, because it's a matter of like monogame is still kind of archaic and old in a lot of ways, especially when it comes to shaders and like their support for certain graphical backends like DirectX or Vulkan or whatever. So because of that, it doesn't necessarily work in the same way. Like just as an example, they don't have compute shaders at all. And they don't you don't really use structured buffers in the same manner. They rely more on textures and stuff, which is like the old way to do it. A texture is really just a structured buffer, kind of. But it's just more annoying to deal with. But it is apparently moving towards more of a Unity approach. But they do have, like, DX12 is coming close. Like, DX12 has been on the way for like 2 years in monogame at least. Could be more. So it's hard to say, but it's like they do have it in preview versions now, so it should be much closer. Version 4.0 aimed to break compatibility with the older XNA API entirely. Okay. I wonder how far away that is. Yeah. We'll see. Like, as much as it is possible, I would like to move the project over to Monogame. But because I'm using such complicated shader solutions, it's not necessarily that easy. Because everything else on the C# side is completely doable, very easily. We need to set in wall equals true in all of these. Okay, so here, you know what? We don't actually need to fetch this here. Maybe I shouldn't do that. Maybe we should only do this on demand. Because this should only happen if we are inside of a wall. So maybe we say if has structure info dot if has structure info, yes. Then we'll say, well, actually, let's and structure info dot in wall is, these are both true. Then we can say this. Don't forget the critical line of code that allows me to pass through walls by sprinting into a plate so I can loot hidden chests. I have no idea what that means. You're sprinting into a plate? This sounds like... Iron glitch. Okay. I was thinking you were gonna sprint into a plate at the gym and then pass out and then hallucinate hidden treasure chests. That works. You would hold a plate to your face, run straight into it, and you'd glitch through the wall. Okay. I actually had never heard of that one. Every day there are new Skyrim glitches being learned about. Oh! Something like that, I suppose. Contains detail. That... What is this set to if it's nothing? I think it's probably 255. Or we just say... We don't do any ifs at all, we just say... Float for detail call equals... Tile... what? Sheet. Where am I storing it? It's like text call 3D, I think. And that's a 3D texture. Then you load based on RC data dot detail tile X int 3 RC data dot detail tile Y and data dot detail tile sheet, and I don't know what this is, if it's like 255 maybe. That needs to be an int 4. And here it's 0. But this needs to be like this. Int. But that's not good enough. It needs to be detail tile X. Times tile size dot X plus position temp Lord tile position. Point tile position. Man, all my variable names are fucking awful. But it's like point tile position, world position divided by tile size. Object tile position, floor tile position is point tile position. Point tile offset. That's the one we want, I think. I don't feel like this should be needed here at all. The point tile offset, I think, should actually be an integer value. But for now, I guess we can just do point tile offset.x. Tile size dot y plus point tile offset dot y, and that's the sheet, right? So that loads that, and that way we just do that. And then we just apply the detail color to the actual tile color. And it just multiplies by... Because that's all we should need to do. Compute tile data. Tile data, detail data. Oh no, hold on. We do this. In fact, we already have it. I don't need to load it like this. I think. Because here we have raycast data contains tile, XY, sheet, status. But then here we have compute tile data, which is XY, sheet, tile state, slice through. Actually, the slice through, I think the tile state is... I don't know. Be there. Because here we are fetching a compute tile data. Uint tile data. Yeah, and then we are splitting it out. Okay. But we still need to load. No, we still need to do this. Because this is just fetching the tile index, kind of. Let me see. Like we have we have to be doing that here somewhere. X call.load. Slice selector. Am I doing anything other than slice selector? Yeah, here, check detail text. C temp. Yeah, offset value. We're actually fetching a pixel color here right away. I'm not a huge fan of that. So here we get the RC data. Then load for pixel color. Yeah. I don't trust the compiler. But I don't think we need this many parentheses. Especially not this one. Tile sheet. Okay, so we don't need this. That's already done. But is there also any reason to not just do that in there? Like, the reason I don't like it is because we're using this, which is like a global. And I would rather it not be a global. Same thing for anything here. Like, it should just be set locally. Here. So here we have an object tile position, and an on-object tile position, and an on-object tile position raw. And none of these should be global. Screen position, world position, like none of these things should be global. I also don't know why they're static, really. These things shouldn't be global. Like, if anything, it should be like a struct that gets passed. Z should not be a global. Because globals are dangerous to use in a shader. It's still really hard to understand, but I think it's dangerous. Is it like... I think it's supposed to, like, potentially keep live registers alive in a way that they shouldn't be. But it's really complicated, so I'm not entirely sure. Kitty cat. Oh boy. I am not here. Oh, Yolan, how's it going? I'm tired. It's a pretty big file, yeah. And it needs some rework, unfortunately. Election. See here, it contains detail. What? What is this? Ah, yes. So we don't need to do this, but what we do need to do here is... Let's see, detail color. I'm calling it detail call now. So we go and just get rid of detail call. Then we can do this. If detail call equals 1011, this is pink. Then we do this. Z equals height map sample. Yeah, this means is it in RC data dot I see that your file seems to end by compute. How come? Is it still a CS file at the end? I don't know, honestly. Oh no. No, CS. CS is a C# file. Now that I look at it. This is a compute shader. Which is a completely different thing. This is HLSL code, not C#. That's why I'm so tired. So structure info. If Z equals structure info dot wall Z min max dot R, I'm gonna go with X. And then detail call is set to that. Alright, so what's happening here... I'm gonna write some comments. We check if the detail color is pure pink, which means it is transparency. Used for doorways or windows in order to make a hole in the wall. Which isn't necessarily so easy for like a window, but if I make the window frame be tiles and then any windows are objects, then it could work. Yeah, sure. Find end of wall. If tilestate.r does not equal 4, this should probably just be cs. No. rc data dot tile state tile status. Or no, isn't this tile type? This is tile type, isn't it? I think so. Building ID. We already have the building ID. So we don't need to fetch that. Because that should just be... structure data. Oh, structure. And see, this is where things become annoying now. Because now... we're fetching a building Z. Which... I think needs to be done differently. Perhaps. Why does it need that, actually? I don't know. Man, this is so complicated. I'll be right back. We are getting really close to the end of the stream. I'm just trying to get some stuff done extra. Oh. Why do I need building Z here? What is happening here? Find end of wall. This is because we are trying to find this is for handling thicker walls, I think. Isn't it? If Z... Oh, yeah, okay. So this is it. This is why we're getting the building Z here only, I think. Um... So we find a horizontal wall. I think there might be other sources of find and of wall. Other than just this. Set first wall. And so what we're doing here is, as we are inside of this building here, we're fetching the Z value of the building. But we already have something here, I think. All we have to do is just say if Z is less than or equal to structure info dot wall Z dot minmax dot x. Then we do that. Building Z. I just don't know if we need that further down. Because it is needed for some things. But we should mainly be using walls. Which should ease it up as well. Because what we'll need to do is... Well, actually, maybe the building should just contain quads. It's just like what we need to do is determined by whatever edge case we might have in the game, right? Like that's what's so tricky about it. Because like let's say you have a building that's like sitting on a cliff face, right? And it looks like this. And then you have like a floor up here. And this here. And then you have like a door here. Down here. And then you have like another door up here. Now this is from the side. Let's just imagine that you stand over here or over here. And then this here is like a cliff side. Right, like maybe this is some kind of stairway house or some bullshit. Now, if I only use... Because I could do that. Just store the building's like boundaries as a rectangle. But then that would be like this. So, if this is the front of the building, the camera is over here. What we want to do is we want to hide part of the building, right? So then that would need to use a different approach. Because should be based on the back wall always, more or less. Even that might be weird, to be perfectly frank. It should maybe be whichever is like lowest on the screen. But like, if you have a character standing here, then like anything above this point here should be transparent, and then here it should taper down and be a gradient transparency. That's why we need to have the wall size. We just need to know really like what is, like, where does the building end? Which is gonna mean like we fetch, we check like in here, and then we find the wall. We find that we're inside the wall. Then we fetch the Z and the Z min and max of the wall, and then we check below one below the min of the Z here. That way we can check if the building ends here or not. And if it ends, then we know that this is the bottom Z, and then we can use that to determine the transparency of the building up. Which will then make actually the front here transparent. And the front should be transparent in a way, because it actually goes diagonally down. So like, it would start becoming transparent here. And then it would have a little roof, right? So anything above this red line be fully transparent. No, anything above this line would be fully transparent. And anything within these two lines would be a gradient. And anything below this would be fully opaque. That's how it would work. But that means that this probably needs to be like somewhat reworked. Yeah, find end of wall. That is just this. So find end of wall is just what we're doing when we're going through a wall that's thicker than one. That's all that is. But it only seems to happen here when we have a transparent detail. Yeah, I guess it doesn't really matter that much otherwise. Hello, Red. How's it going? And then here we have, if z is greater than 0, then we need to check ahead. Maybe we load these all the way down there only. Like that. I don't think that's needed there. Tile state.r. This is RC data tile type. Detail color detail call dot a. Handle roof transparency. This one we'll have to see if this works out. But I think this shouldn't matter. Because I actually removed the roof, and now we only have rooms. So the roof just counts as a room that's on top of the building. And that's it. And here we have an array of colors. Now tile state B. I think this is like the building. And this is what's annoying here, because now I can't just do an easy check like this. Now we have to have a function that takes the buildings and like takes the building that you're trying to check, so that we can return a boolean there. But yeah, I think we'll stop there. Like I've been struggling for like an hour. This is too much for me to do this late into the stream. This is not easy. And this is really old too, so unfortunately some of it might need to change. And hopefully we can figure out some better way to do things here, but we'll see. But this is very complicated because there's like infinite edge cases and stuff. And here we're casting light. Hello, the Weird Duck. How's it going? And each tile that we find needs to do a light cast. Which means that if the tile is transparent, then we need to light cast and then continue and then light cast the next one too. But that's fine. I'm tired and I'm gonna take a break now. And maybe see what else needs to be done that isn't programming right now, that I still have brain power to manage. Maybe I'll start sketching Semper's ratfish a little bit. Try to figure out how big it needs to be. Probably pretty big. But yeah. That'll be enough programming for now. Like I said, tonight we'll be streaming Final Fantasy XIV on the Bickering Bunch channel. So I won't be back here until tomorrow. But yeah, I'm gonna go and listen to the audio drama we have and give some feedback to Robert. See what else I can figure out. We're definitely done programming. My brain is completely fried. But yeah. Until next time, thanks for hanging. Have a good day. Bye-bye.